In this problem we are going to solve this circuit, and what is the question here? The question is asking find the Thevenin equivalent circuit for the given figure. Okay, now Thevenin equivalent circuit means what? We have to represent this circuit as a combination of a voltage source and a series resistance. So, this will be your VTH and it will be your RTH, and we have to represent the circuit as a combination of VTH and RTH. So, now in this circuit you can see here that, so one dependent source is there. So, this is the dependent source. Okay. Now, whenever there is a dependent source, the approach to solve the circuit is little bit different from as usual. So, first let us know that how to solve this circuit. Okay. So, for if there is a dependent source, so if there is a dependent source, then what we have to do? Step 1 is find VOC, find VOC or the VTH, whatever we can say it. Find VOC as usual. As usual means the previous whatever method we have used to find the VOC, make these terminals A and B as open circuit and then find VOC, we will follow the same way. Then second point is what? We have to find the RTH, and here the calculation of RTH is the bit different process. So, RTH value is equals to VOC that we have calculated divided by one new factor that is called as the ISH, or it is also called as the shunt current. Now, how this shunt current is done? So, it is done by a short circuit. So, by doing a short circuit where across the terminals AB, means wherever we need to calculate across the terminal AB we have to do it. Okay. So, this is the different process if there is a dependent source and both dependent source and a regular voltage source or independent source is there, then this is the process. Okay. So, now let us start how to solve it, and in the circuit these values are given as, this one is given as 4 ohm, this is given as your 2 ohms and this is given as your 4 ohm. So, first step is to find the VOC. So, VOC is available here. How to find? So, VOC we can find if I consider one current is flowing here, let us say that current is I1. Okay. So, VOC you can find out with help of a mesh analysis. So, how do we find the VOC? If I apply KVL here, so if I apply KVL in this loop, then what I will get? So, I will get 12. So, I am starting from here. So, 12 minus 4 into I1 I can write. So, here 4 into I1, again it will be plus 2I. Okay. So, plus 2I will be there. So, where is the I is flowing? So, the current I is flowing in this circuit, or this is the I1. Okay. We can write 2I minus 4 ohm is here. So, we will write 4 I1. So, here also I1. So, that is equals to 0. Now, if we solve this, so what we can get? Directly one variable is there. So, directly we can get I1 value is equals to your 2 ampere. Okay. How it is 2 ampere? So, if we just solve this, so it is 4 then 2, then it will be 4 12. So, we will get 2 ampere as the answer. Okay. So, next is what? Next we have to find the ISH. So, how do we find the ISH? To find the ISH we have to make this a short circuit. Okay. So, we have to make this as a short circuit and ISH current will be flowing here, and in which direction it will flow? We will consider that this is flowing in this direction, because here the current is flowing from this side and it will be getting divided here. So, we consider that the current is flowing in this direction. Okay. Okay. So, one thing I forgot to mention here. So, if we got I1 as 2 ampere, then your VOC value will be how much? VOC is the same across whatever voltage is available here. So, this will be your VOC. So, VOC you can do, this resistance is 4 into 2, that is equals to 8 volts. So, that is your VOC. Okay, this is the one value we got. Next is we have to find the ISH. So how do we find the ISH? So to find the ISH, we have to write two equations in the two loops. So if I consider that I1 current is flowing in this loop, in the first loop, and your I2 current is flowing in the second loop. So if I consider like this, so this ISH I can get it from here. So now if I write the equation applying mesh analysis, so I am calculating for this ISH. So for the first one, what I can write? So I'll just zoom out. Okay, so here I can write 12 minus 4i, okay, plus 2i minus 4 whole into I1 minus I2 is equals to 0. So I am applying the mesh analysis in the loop 1. So this is my loop 1. Okay, so this one is my loop 1. So if I apply it here, I will get this equation. And what you can substitute, what is the value of I? So the value of I, so initially the I current was flowing where? The I current was flowing here. Okay, so this was the I current. Now what is the value of I now? So we can write I can be replaced as, if I am considering the first loop, so I is equals to I1 minus I2. So the value of I is I1 minus I2. Then this value we can replace here. So this equation can be now written as 12 minus 4i plus 2 whole into I1 minus I2 minus 4 whole into I1 minus I2 is equals to 0. So this will be my equation number 1. So again if I solve this, so here it will be 2 minus 2 I1 into I2 and then 12 4. So I will get here 3 I1 minus I2 is equals to 6. So if I solve this one, I will get, so I will consider this as my equation number 1. Okay. Next in the loop 2, what I can write? So see here in loop 2, so 2 I2 into, sorry, so here plus minus, so 2 I2, here I can write minus 4 whole into I2 minus I1. Okay. So for loop 2, so this register is there in loop 2 and this register is there. So I can write here 2 I2 plus 4 whole into I2 minus I1 is equals to 0, and this is my loop 2. So if I now use using calculator, I can solve these two equations here. So if I solve the two equations, then I will get I1 is equals to 3 by 2 into I2, from here I will get, and replacing that in the other value, I will get I2 value is equals to 12 divided by 7. Okay. So you can do the calculations, I am not doing the calculations. So through calculator also you can get the values directly. Now if I2 value is 12 by 7, so this I2 value is flowing where? This I2 value is flowing here. That implies my I2 value is equals to ISH. So now what I need to find? I need to find the RSH. So RSH is how much? VOC divided by ISH. Okay. So that will be equals to 8 divided by 12 by 7. Okay. Finally we can get the value as 14 by 3 will be the final value. Okay. So now the final value, the final circuit, how I can draw? So I can draw a voltage source here whose value is 8 volt, taken like this, and then one resistance value here whose value will be 14 by 3. Okay, and here the point A and point B is there. So that is how we can solve this problem, and this will be your final answer. So this is the answer that the question needs to be solved for. Okay. So this is it, and then in the next problem we will see how to solve the or find the Thevenin equivalent if there is only one dependent source is